This module introduces the A320 electrical system. The electrical system provides both alternating current and direct current power to operate the aircraft systems. AC power can be generated on board, and when on the ground, AC power can be provided by an external AC power source. The aircraft is equipped with 5 methods of onboard generation of AC power: 3 generators, 1 emergency generator, and a static inverter. Let's look at them a little more closely. There are 3 AC generators installed. These generators are the normal source of AC power. There is one on each engine and one on the APU. The generators are rated at 90 kVA. Normally during flight, AC power is supplied by the engine-driven generators. When the aircraft is parked, AC power may be provided by the APU generator or an external ground source. The aircraft is also equipped with a ram air turbine, RAT, hydraulically powered emergency AC generator that automatically operates in flight if AC-1 and AC-2 buses are not powered. The emergency generator is not considered one of the normal operating generators. In the event that no generators are available, a static inverter is installed to provide yet another source of AC power. The inverter converts DC power to AC power and is powered by battery 1. Please review the 5 methods available for the aircraft to provide onboard AC power. Now we'll describe the sources of DC power. Aircraft DC power is normally provided by converting AC power through the operation of the onboard transformer rectifiers, TRs. There are 2 normal TRs and 1 for essential power. The normal TRs can each supply the DC system with up to 200 amperes of DC current. The essential TR can power the essential DC circuit from the emergency generator if all normal generators have failed, or TR1 or TR2 has failed. Each TR controls its contactor by internal logic. An alternate source of DC power is the 2 aircraft batteries, designated Battery 1 and Battery 2. Each battery has a normal capacity of 23 ampere hours and is permanently connected to the respective hot bus. Each battery has an associated battery charge limiter, BCL, that monitors the battery charge and controls the battery contactor. Okay. Let's look at the electrical system diagram. The electrical system consists of left and right sides. The 2 sides are normally isolated by 2 open bus tie contactors. In flight, each side is normally powered by the respective engine-driven generator. To improve dispatch reliability, and with some operational restrictions, the APU generator may substitute for an engine-driven generator. In this case, 1 bus tie contactor will be closed for the side that the APU generator is powering. While only 1 generator is operating, it can power both sides of the electrical system through the bus tie system. You should know that although 1 generator can power both sides through the bus tie, there is never a time that generators are paralleled on the same buses. The 1 operating generator could be one of the engine generators or the APU generator. Okay, you've learned that there are 2 engine-driven generators and 1 APU-driven generator. All 3 generators are identical and provide the same capacity. The generators provide 115/200 volt 3-phase, 400 Hz AC power. Any one generator is capable of supplying all essential AC power to the aircraft. Each engine generator has a generator control unit, GCU. The GCU controls the output of each generator and provides protection to the electrical network. Specifically, the GCU controls the voltage and, through the integrated drive generator, the frequency of the generator power output. While the generator output is normal and there are no system faults, the GCU will command the generator line contactor, GLC, to close and allow the system to be powered. If the generator output is abnormal or if there is a fault in the system, the GCU will command the GLC to open. The Ground and Auxiliary Power Control Unit, GAPCU, provides similar functions for the APU generator and external power that the GCUs provide for the engine generators. For the APU, in order to maintain a constant voltage and frequency, the generator drive speed must remain constant. Since the APU generator is directly driven by the APU, the drive speed of the APU generator is maintained by control of the operating speed of the APU by the GAPCU through the ECB. For external power, if the ground power source is normal, the GAPCU will allow the external power to be selected on and power all buses. The engine-driven generators are each driven by an integrated drive generator, IDG. The IDG provides a constant drive speed to the generators, regardless of the engine operating RPM. If the IDG malfunctions, the flight crew can disconnect it from the engine drive, thereby shutting down the respective generator. Earlier, you were introduced to the emergency generator. The emergency generator is driven by hydraulic pressure from the blue hydraulic system. The emergency generator can also receive this hydraulic pressure through the operation of the ram air turbine, RAT, that automatically deploys during a total loss of normal AC power. The emergency generator is rated at 5 kVA, 115/200 volt, 3-phase, 400 Hz AC power. It can provide power to the essential AC bus and through the essential TR to the essential DC bus. If no other source of electrical power is available, Aircraft Battery 1 can provide a limited source of AC power through a static inverter. The static inverter is rated at 1 kVA and provides 115 volts, single phase, 400 Hz AC power. Now we have an overview of the system components. Let's look at the electrical system diagram. The diagram flows generally from the bottom to the top. AC power is supplied by an engine generator, the APU generator, or external power. On this frame, we show the engine generators providing the power. As shown here, the bus tie contactors are normally open and the engine generators are online to power their respective side. Power flows from a generator through a generator line contactor, GLC, to the respective AC bus. The AC power flows from the AC buses up to the associated transformer rectifier, where the AC power is converted to DC power. Notice the AC Essential bus. It is normally powered by AC Bus 1, but can also be powered by AC Bus 2 or the emergency generator, or even the AC static inverter if necessary. The AC Essential bus normally powers the AC Essential shed, and as its name implies, the AC Essential shed can automatically shed to reduce the electrical load on the AC Essential bus. Okay, let's go back to the DC power. After the power is converted by a TR, the DC power normally flows to the respective DC bus and then on to the DC battery bus. From the DC battery bus, the DC power normally flows down to the DC Essential bus and then to the DC Essential shed. The powered DC battery bus also provides power down through the battery contactors to the Hot Bus 1 and Hot Bus 2, and then to the respective batteries for charging. Take a moment to look at this diagram and imagine how power would flow if it was provided by the APU generator or external power. When APU or external power is online, the bus tie contactors will close to allow the APU or external power to deliver to both sides. Here we show a loss of all normal power sources. Look at the emergency generator. It can power the AC Essential and DC Essential buses when no other generator is available. It takes 8 seconds for the RAT to deploy and the emergency generator to produce power. During the 8 seconds, batteries and the static inverter keep the AC Essential and DC Essential buses powered. As another backup power source, the static inverter can power the AC Essential bus, while at the same time, battery 2 can power the DC Essential bus. The static inverter operates if the aircraft has no other power except the batteries. All right, we have an overview of the system diagram. Let's locate the controls and indicators in the flight deck. The controls and indicators in the flight deck consist of the electrical panel, the emergency electrical panel, and the ECAM electrical page. Take a look at the panels and displays as they are shown here with a normal in-flight configuration. The ECAM electrical page displays the system similar to the diagram we have used. Let's briefly look at how you will use this system in normal everyday operations. When you arrive at the aircraft, you'll notice that external power is plugged into the aircraft, and you'll want to turn on the external power. But first, you'll perform a visual check of the battery voltage before each battery switch is selected to auto. Then, after each battery switch is selected to auto, you'll verify the external power is available, and then you'll select it on. External power will then be applied to both left and right electrical systems. Sometime before pushback, you'll start the APU. The APU generator does not automatically disconnect the external power, so if you want the APU power applied to the aircraft, you'll have to turn off the external power. When the external power is no longer in use, ground personnel can disconnect it from the aircraft. The engine generator switches are usually in the on position. Upon engine start, the engine generators will automatically power their respective side of the electrical system, and the previous power source will be disconnected from that side. After the engines are both started and the APU power is no longer in use, you will shut down the APU. The electrical system will be monitored throughout the flight for normal operation. No other duties are required. After landing, you will normally start the APU, or, if the APU is inoperative, wait for external power to be plugged in at the gate. If the APU is running when the engines are shut down, the APU generator will automatically power the electrical system. After landing, you will normally start the APU, or, if the APU is inoperative, wait for external power to be plugged in at the gate. If the APU is running when the engines are shut down, the APU generator will automatically power the electrical system. If the APU is not used upon arrival at the gate, and the external power is plugged in, you will simply select the external power switch to on. Since the engine-driven generators have operational priority over external power, they will continue to power the electrical system until both engines are shut down. Note: you won't want to shut down the engines until external power is available and selected on. Let's finish this introduction with some simple rules. If you select the external power to on, it will not come online until a higher priority, engine generator, is removed. If you select the APU power to on, it will not come online until a higher priority, engine generator or external, is removed. When an engine is started, it comes online to its respective side. If neither side is powered, the engine generator powers both sides. The order of the bus power source priorities is: 1. Engine generator to on-side bus. 2. External power to unpowered bus or buses. 3. APU to unpowered bus or buses. 4. Opposite side engine generator to unpowered bus. Let's answer some questions for the information presented in this module. This module will demonstrate the electrical system normal operations, while also providing a description of the controls and indicators. The electrical control panel holds the switches that are normally used to control the electrical system. An emergency electrical power panel holds the switches that are used for emergency electrical conditions. An external power panel holds lights that indicate the availability and usage of external ground power to persons outside the aircraft. The ECAM electrical page provides the synoptic display of the electrical system to the flight crew. It can be displayed at any time by pressing the electrical button on the ECAM control panel. A maintenance bus switch allows maintenance and service personnel to energize only the circuits required for ground servicing without energizing the entire electrical system. The switch is a magnetic type switch that will latch in the on position if external power is available when the switch is selected to on. A commercial switch is installed on the electrical control panel. Notice the items controlled by this switch. A galley and cabin switch is installed on the electrical control panel. Notice the items controlled by this switch. We begin our description with the electrical control panel and the ECAM electrical page. We'll show the controls and indicators in action during a normal flight sequence. The switches on this module are operational and provide free play training. Initially, the aircraft is not powered, and the ECAM electrical page is blank. Verify the unloaded battery voltage on the displays is within limits. The battery voltage minimum is 25.5 volts. Click on each battery switch to select it from off to the auto position. Notice that some lights come on when the first battery switch is selected to auto. The auto position allows the batteries to power the DC battery bus and the DC essential bus when no AC power is online. Therefore, you may notice a slight dip in the battery voltage now that the batteries have a load applied. The green available light in the external power switch indicates the power is plugged in and is of good quality. To apply the external power, click the momentary action External Power switch. The external power line contactor closes, and AC power is delivered to both sides of the system through the bus tie contactors. Accordingly, the avail light goes out and the on light comes on blue. Now that normal power is on the aircraft, the ECAM is available. Notice the indication of power flow by the green lines. The batteries are now charged by external power, and the ECAM shows green arrows to indicate the flow of current to the batteries. You can now visually follow the display on ECAM and compare it to the electrical system diagram. The amber indications show items that are not powered, green items are powered, and arrows show the direction of current flow. We now simulate a starting of the APU. When the APU is up to speed, its generator power is available. You can see the change on the ECAM electrical page that shows the APU generator load, voltage, and frequency. The APU generator switch is normally left on, but notice that it does not pick up the load. Switch off the external power switch. When the external power switch is selected off, the blue on light in the switch goes off, and the green available light illuminates. Now, the APU generator is online, and the ECAM electrical page shows a load on the APU generator, and external power is no longer online. Notice the flow of power from the APU generator is indicated by the green line. The crew will now request ground personnel to remove the external power. The available light goes out, and ECAM no longer displays external power. Notice the engine generator switches are both in the on position, and the fault light is on in each switch. The on position energizes the generator field, and the associated line contactor will close when the engine generator power is normal. We'll now demonstrate a start of engine 1. The fault light should go out when the respective engine is started and its generator operates. During engine start, the IDG will be driven. Observe that the IDG fault light illuminates momentarily, then extinguishes, and that the IDG temperature on the ECAM begins to rise. If your aircraft has the rise feature installed, after the engine is running, you'll notice the rise temperature begin to display in green. This display indicates the difference in oil temperature from the intake of the IDG oil cooler to the outlet of the IDG. Excessive rise temperatures may indicate over or under servicing of the IDG oil, among other problems. When engine 1 starts, the generator voltage and frequency will increase until they are at normal levels. When normal levels are reached, the generator 1 line contactor closes and the bus tie contactor on the left side opens. The APU continues to power the right side, while engine 1 generator powers the left side. Observe the change on the ECAM electrical page. When engine 2 is started, the process is repeated for the right side. Each engine generator is now powering its own side, and both bus tie contactors are open. When the APU is shut down, the bus tie is no longer powered, and only the APU generator title remains displayed on ECAM. This would be the normal display of the electrical system until the aircraft arrives at the destination. When the APU is started after landing, the ECAM electrical page shows the voltage and frequency. When the APU generator switch is selected on, the APU generator contactor closes as long as the external power contactor is open. APU power will not be delivered to either side of the electrical system until the associated engine is shut down or the generator is off. When engine 1 is shut down, the APU picks up the left side. When engine 2 is shut down, the APU picks up the right side. Now the APU is powering the entire system. When electrical power is plugged in and of good quality, the green available light comes on, and ECAM shows that external power is available. Pressing the external power switch closes the external power contactor and opens the APU generator contactor. The external power is now applied to both sides of the electrical system. If the aircraft is to be completely shut down, the external power should be switched off and the batteries should be turned off. This completes the demonstration of normal electrical system operations. We will learn more of the switch functions in the discussion of abnormal operations. Now let's answer some questions.